Today's guest is Graham Lau. He is an astrobiologist and communicator of science. Many people know him as the Cosmobiologist. He's a director of communications and marketing for Blue Marble Space. He's a research scientist with the Blue Marble Space Institute of Science. He serves as the director of logistics for the University Rover Challenge. He hosts the NASA Astrobiology and Sagan show Ask an Astrobiologist. He is the research community coordinator for the Hypothesis Browser and the Life Detection Forum's knowledge base. I'm Felix Tuchinski, and this is Humanity and Beyond. So, how are you doing today?
Quite well. It's been a good day. We just had some interesting conversations throughout the day with some folks from NASA about some upcoming workshops and things that we're planning. So, a lot of cool stuff in the works.
We'll have to talk about that in a sec. But it's one really exciting questions I've got for you is, could you explain the phosphine finding on Venus for us, please?
Absolutely. It's a very cool finding, but it might not be a finding. So let's talk about it.
All right.
First off, we've discovered phosphine beyond the Earth already. We've discovered phosphine. We've known for several decades now that there's phosphine in the atmospheres of Jupiter and Saturn. And our current knowledge of how it's forming is that it's forming in very high pressure, very high temperature environments lower in those atmospheres, and then making its way to the outer parts of those atmospheres where we can measure it. And this phosphine molecule is forming in hydrogen-rich atmospheres on Jupiter and Saturn, where it's far more likely to form abiotically, or without life. The finding on Venus, or potential finding, is a little more intriguing. Here on Earth, we find phosphine in a number of ways. We can form it in the lab industrially, and we can use it for various chemical reactions. But the only way it forms naturally on Earth is through biological processes. Specifically, there's organisms in what we call anoxic environments with very little oxygen, that can form this molecule. And it forms in some other weird places, like inside of some guts and penguin poop and some other cool places. But it's all biological. And this molecule, phosphine, it's kind of like methane. So methane is a carbon atom with 4 hydrogens bound to it. Phosphine is a phosphorus atom with 3 hydrogens bound to it. It makes 3 bonds with hydrogen. And so you'll see it written as pH3 in some of the news publications and things like that. And what they found with Venus, so the astronomers who predicted this finding, they did predict it first. They thought they might find phosphine as a biosignature, not just on Venus, but they were looking primarily at exoplanets, suggesting that if we find phosphine in the atmosphere of a world that wouldn't have the chemistry of a Jupiter or a Saturn, that the phosphine itself could be a sign of life. So what happened, the lead author of this newest article, Jane Greaves, she had set out specifically kind of looking for this phosphine using a radio telescope called the James Clerk Maxwell Telescope in Hawaii, looking at what we call millimeter band astronomy, so a certain wavelength of radio waves that we can see coming to us from Venus, looking for how molecules, chemical molecules, interact with that radio, those radio waves. And what they found was one little dip in the amount in the radio waves coming to us from Venus in a region that could correlate with being phosphine. And that was a pretty exciting finding. Jane Greaves said that she spent something like 18 months convincing themselves that it was real, that they really found what they thought they did. And so then they made another measurement with a much better telescope, or a stronger telescope that can get higher resolution data, called ALMA. That's the Atacama Large Millimeter Submillimeter Array down in South America. And with ALMA, they found that exact same dip in the pattern. Unfortunately, though, it's just one dip. It's one line, as we call it in spectroscopy. So instead of having several different regions where they can show a diagnostic for this molecule phosphine, they only have one specific line. And so that's problematic for spectroscopy. Also, there are other molecules that actually could be causing that absorption and causing that line to occur. One of those molecules is sulfur dioxide. And we know that the Venusian atmosphere has a lot of sulfur in it. It's very rich in sulfuric acid. There's a lot of sulfur in Venus's atmosphere. And so it might not even be phosphine. which is kind of a bummer, but it's still very important research. Because if it is phosphine, then we have good reason to find out if it's there for one thing, and if it's not being produced by life, then there's some kind of other photochemistry or volcanism or something going on Venus that we need to understand. And if we're going to use phosphine on exoplanets as a potential biosignature, then we really need to figure out, if it is on Venus, whether or not it's coming from life, because maybe we find phosphine in a bunch of exoplanets and it means almost nothing and is being produced abiotically in all these other worlds as well. And that's really good for us to know. And so there are some upcoming missions that could get some of that data for us. You haven't heard this a lot in the news, unfortunately. Bepi Colombo is a mission that's going to Mercury right now, and it's actually flying by Venus next month. Actually, I guess this month. It's October already. It's flying past Venus here in October. We don't really have time for the people running that mission to do much in changing that flyby, but it actually has another flyby next year in August of 2021, and it also has instruments on board that could potentially detect phosphine if it's there. And so we could, by late next summer, actually know if that finding was real or not. That said, the way the science works, one thing you're going to find right away, and it's already happening. I've seen some of the papers already. They're not published yet, but they will be very soon. There are people already trying to figure out whether or not the phosphine is there, and if it can form abiotically or not. And there's a lot of really good research going on already.
So how likely is it that it's life and not an abiotic process? Or is it hard to tell right now?
It's very hard to know right now, because all we have is a potential detection of this phosphine. And again, on Earth, it doesn't form naturally outside of living processes. But that doesn't mean it can't happen on Venus. We've actually kind of understudied Venus. We really haven't had many missions go there. We've had some good ones, but just not enough. And so maybe what we're really lacking is an understanding of the atmospheric chemistry within Venus and the surface geology. Maybe there is some active volcanism occurring that we just haven't been seeing, and that's explaining the phosphine. And so there's a lot more for us to learn. A life detection, actually finding alien life, it's the holy grail for us in astrobiology, but it's also something we're very cautious about and very skeptic about until we have very good evidence.
Right. And for those of us that are less skeptical, how do you think the communication in the media could be improved?
That's a wonderful question, because it's always going to happen. It happened with the Viking biology experiments. It happened with the Allen Hills meteorite called ALH 84001 back in 1996, when Bill Clinton walked out in the White House and announced that we found life in a Martian meteorite. It happened with the arsenic life fiasco, as some people call it, even though it was still good research that deserved to be published, but should have been questioned more thoroughly. And now we have this current issue with this potential phosphine finding. The issue is that a lot of time we have a lot of journalists who don't understand necessarily the science or the scientific process, and maybe are too quick to try to get the most catchy headline. And while that can make for some fun reading, it can also be very misleading, especially when we have a society, as Carl Sagan once remarked, that is exquisitely dependent on science and technology, where remarkably few people really have any understanding of science and technology. And that's not necessarily just the journalist's fault, or the publication's fault, or the media in general. That's on all of us. All of us together are failing in educating ourselves in critical thinking to really make sure that we're not just buying the first thing we're sold. For all of our issues on this planet, right? I mean, in everything that we do, if we really taught ourselves more critical thinking early on, we could avoid many of our problems.
Why are your hypotheses more about life more toward more Venus leaning, I should say? Sorry, I can't speak scientifically at all. But you seem to have a strong scientific consensus, at least in your own mind, that Venus is far more likely to host life, even if this phosphine is not being generated by life. We're more likely to find life on Venus than Mars. And could you explain your reasoning behind that?
Yeah, I definitely want to clarify that. When I say that, I'm actually not discussing the modern day. When you've heard me say this before, I've been on various podcasts and live streams and things like this and television shows and whatnot where people hear me say this, but what I really say is that if I had to make a bet in the very early solar system, if there were any other world besides the Earth that most likely had life, I would put all of my money on Venus and not Mars. Even though we do have much better research nowadays to show us that Mars was likely very wet in the distant past and had rivers, potentially seas, maybe even an ocean. And we have more knowledge now on ancient Mars, and maybe Mars did host life. But early Venus, I mean, it was so much more like the Earth. It's very close in the size and gravitational characteristics of the Earth. It may early on have had some plate tectonics. We really don't know. It is lacking a moon, as we have, to stabilize our obliquity. But Venus early on very likely had a more clement atmosphere, like we do, and might have even had large oceans. Just Venus has undergone two very remarkable processes. One is that within the last 500 million, or up to a billion or so years, it looks like nearly the entire surface of Venus melted. So all of the rocks went molten. There's no plate tectonics left that we can see any remnant record of. And the surface seems to have just melted out entirely and be covered in lava. And then the atmosphere underwent this runaway greenhouse effect, which likely started happening before the surface did that. And the runaway greenhouse effect on Venus is what could happen to us if climate change goes unchecked for too long in one direction and there's not enough homeostasis bringing it back into a regular cycle. When the greenhouse effect runs away to that extent, then you end up with what Venus has, with a surface close to 900 degrees Fahrenheit and 92 times the surface pressure that we have now. Life as we know it can't survive on the surface of Venus. It's not possible for life as we know it.
So here's an interesting thought experiment. What is it? Panspermia? Is that the correct term?
Mm-hmm.
What would you say to the idea that life on Earth could have come from Venus?
I love it. Yeah. So and panspermia is a very cool idea. The term itself, panspermia, means seeds everywhere. So pan is all around us. Spermia is the production of seed. So panspermia means seeds everywhere, and it's this idea that life could be spread on rocks, on celestial bodies throughout our solar system, maybe throughout the galaxy and the universe. We don't fully know. The idea is actually very old. It comes from an ancient Greek named Anaxagoras, but only in more modern times have we really started doing research to show that it seems entirely plausible that life could survive the process of a planetary impact. When a large asteroid or comet bombards a planet, and some material is launched in that process with enough velocity, it actually attains escape velocity and can leave that planet and go and get lofted into space, which is how we have meteorites that landed here on Earth from Mars. There's a very good chance we have ancient rocks from Venus here on Earth, but we don't know enough about the Venusian rock from long ago to know whether or not we do. Likewise, there's most likely ancient rocks from the Earth on the surface of the moon. We might even have ancient records of some of the earliest Earth life waiting for us to go find on the moon if we just get over there and look for some of those Earth meteorites. And so the idea of panspermia is entirely plausible. We don't have any evidence yet that it ever occurred. And so sometimes you'll see certain people, they really, really want panspermia to be true. And so they try to do what they call research, even though it's not very well structured and not really well peer-reviewed at all. And they'll say, we have evidence of panspermia, but that's really not the case. We've never had good, strong evidence that panspermia has occurred. That said, we still have a lot of issues in figuring out the origins of life. And I think we're getting closer and closer to figuring out not only one way, but maybe several ways that life could start on a planet. But we still don't know how life started here on Earth. And so maybe, just maybe, life started on Mars or on Venus first, or maybe it came from somewhere else. And maybe life really is much older than we think. But we just don't have any evidence of that yet, and that's the problem with that thought.
We'll be right back. We just wanted to thank all our listeners, and especially our supporters. Without you, all of this would not be possible. If you want to support us, you can do so just by following and sharing us on social media. Coming up is our community question. If you want the chance to have your question featured, just tweet at Humanity X Beyond. You commented for a second on how these particular researchers maybe aren't defining their research terms well enough, or just don't have their articles peer reviewed enough. What kind of research are you focused on? What are you working on right now?
Yeah, I mean, so I've kind of put my hands into a lot of different pots, honestly, in the sciences and in communication of science. A lot of what I do currently is communication of science. I'm doing a lot of work and just trying to spread the good word, and trying to do a lot of work and just getting science out there to different people and teach. And then I have my show with NASA called Ask an Astrobiologist, where I talk to other astrobiologists about their work, and it's a lot of fun for me. My personal research, though, is in geochemistry, trying to understand how one specific environment in the Canadian high Arctic can be used not only for better understanding some processes of life here on Earth, but also as an analog for looking for life on Mars, as well as looking for life on Europa.
Is it just similar temperature and pressures, or?
So it's interesting, right? When you hear someone say, like, you have an analog environment on the Earth, of course, it's not exactly the same as the other places. The surface of Europa, for instance, is extremely cold. There's a lot of radiation. But what we have in the Arctic, in this valley called Borup Fjord Pass, is a glacier. It's a coalescence glacier in the middle of this valley. And at its base, in the summer times, we've observed spring fluids coming up from the subsurface at the toe of the glacier, and sometimes even like coming through the ice of the glacier, giving us a chance to understand how fluids moving through ice can be measured at the surface and teach us more about the subsurface. It also gives us a chance to understand how, and so these springs coming out, they're very rich in something called hydrogen sulfide. It's that smell of rotten eggs. And you'll smell it a lot like around Yellowstone National Park or like Volcanoes National Park in Hawaii. It's also released a lot around volcanic settings and geothermal settings. And this hydrogen sulfide is at the surface being converted into what's called elemental sulfur, a really beautiful yellow mineral. And so when you're flying over in a helicopter or an airplane, you look down across the entire surface of this glacier, you see yellow everywhere. And it's very pretty to see, and it also gives us a chance to understand how these organisms, microorganisms that thrive in this environment, are living in this sulfur-rich environment, and how they're using the sulfur for the chemical energy. And so we have an analog for Europa. We have a way for studying sulfur biology and sulfur geochemistry. And then in this valley itself, we have these mineralogical features that we call gossans, very similar to what's called a gossan here on Earth, where and miners might have heard this term. It's an old Cornish mining term. Sometimes they're called red hats as well, or red caps. This is where on the surface you see a bunch of like a big circular structure, and it's mostly red because of the staining from iron oxides and other iron minerals. And what it is, it's the leaching product of having an iron-rich ore in a vein near the surface. And so as it's being leached by surface fluids, the chemistry is causing it to create these iron oxides. And it's actually a very potentially good analog for research on Mars. We have reason to believe these gossans, these features, could exist on Mars, and they might be a good place to look for life.
And I guess you have action behind your effort, because you're leading this organization called Blue Marble, with its role in distribution and communication of important reports. And I'm assuming maybe it tries to slip in those teachings of science philosophy in the meantime.
I would argue that a lot of people at Blue Marble Space and Blue Marble Space Institute of Science are actively interested in the philosophy and in learning more about our place in the cosmos. I should be clear, I don't lead the organization. So I'm the Director of Communications and Marketing for Blue Marble Space and a research investigator with Blue Marble Space Institute of Science, which are actually two different things. My friend Sanjoy Som is the CEO and founder of Blue Marble Space, and then our colleague Jacob Hawk-Misra is the director of Blue Marble Space Institute of Science. But within our organization, within the Institute of Science itself, we have now over 60 scientists, 60 different research scientists in our organization, working in a whole slew of different kinds of research in astrobiology and space science and earth science, who have a lot of different perspectives and backgrounds to come together in our organization. But it is a pretty awesome group to be part of.
Yeah. And how does one become part of that group?
Yeah, so there are various ways. So first off, for undergraduate students or recent graduates from college, we have something called the Young Scientist Program. That's where all of us who are research scientists, research investigators, senior research investigators, we can bring on students to work with us on very specific projects. We have one program that's run through NASA Ames, and so the PIs, the project investigators, are NASA Ames scientists. And then we have an online version of this program run by our scientists, where anyone from around the world can take part in this program. It's online, and it's mostly through the summer. And this summer, I had 19 interns working with me this summer on the project.
Wow.
Some of them will continue working with us moving forward too, and maybe one day become scientists with us. And then after that, some of them can become visiting scholars. If someone's working on a master's degree or a PhD and wants to get some extra experience in research or working with one of us in another project, they can become a visiting scholar with us. And then we also have postdoc positions. People who just finished their doctorate can apply to be postdocs with us through our scientists if they have funding and projects available. And then after that, then for people who've actually finished their PhDs and are scientists, they can actually apply to join Blue Marble Space Institute of Science as research scientists. And the process isn't too bad. We have a page on our website where people can learn more about that if they're interested.
So theoretically, somebody could join as an undergrad and then eventually finish their postdoc within the organization. That's kind of cool.
Yeah, if you're a college student, if you're an undergraduate college student, and actually this past year I took one student who just finished high school.
Wow.
She was going to start college this fall, but because of the pandemic, she's putting it off. But I was still happy to have her join me on my project this summer. And so, yeah, so we do have some ability, some opportunity for younger students as well, but it's mostly at the collegiate level.
One of my last questions here is, if you got the opportunity, most likely it'll probably happen in the 2040s or 50s. If you think you'd be up to the challenge of going to Venus yourself?
Yeah, I'd do it. I mean, obviously, getting humans to the surface of Venus is going to be highly unlikely until we get some better material science and know what we're doing. But say something like a HaB was a concept design from NASA for a high altitude Venus balloon project, this orbiter that would send a balloon down into the atmosphere of Venus with a 2-person crew, and then the crew basically detach on a rocket and then head back off and then come back to Earth. I would totally do that if I could. That'd be a blast to go and just bask amongst the Venusian clouds where life might be or not. And even if it's not there, it'd still be cool to go and just have that experience. I mean, we humans are explorers. We're curious beings, and we have this drive inside of us to get out and learn more. And being part of that is always a blast.
If we have that philosophy of science, I guess, because there's some people who are very much happy to stay at home and go to work every day.
You'll often hear, I mean, and this happens to almost all of us in space exploration and space sciences anyway, where people are like, the common phrase is, why are we still going to space? Or why are we wasting money on space when we have so many problems here on Earth? And the sad thing about that is often, I think those people are really going after the wrong folks, because a lot of us in space exploration, we value the Earth so much. We value the overview effect. We value this process of looking back at ourselves and seeing ourselves together. We value the biosphere. A lot of people who are involved in space sciences are also involved in sustainability research and climate change research and all these other kinds of realms where we want to protect and preserve our planet. And so it's kind of unfortunate. And also, we're not really wasting money on space. We actually have a lot of data to show that there's a huge payoff from space exploration. Not just in learning more about our place in the cosmos and learning more about climate change and things like that and having Earth-observing telescopes, but just in all of the material science and all the benefit we've gotten to our societies in general. Things like water filtration to ways of preparing our food, all kinds of industrial processes that we've gotten because of going to space. There's a magazine called NASA Spinoff, and it's been produced for a very long time now. And every single year they release a new issue showing some of the major technological advances that have come from space exploration that year. And unfortunately, those people who keep saying that we waste money on space, they almost never seem to take the time to look and see what we actually are getting out of space. And it's way more than the nothing that they think it is.
Yeah. And I don't even, I mean, people always complain the International Space Station has cost like $150 billion or something, but they divide it over its 20-year lifespan and going, and then think about just, I mean, even the medical research alone. I spoke with I wish I could remember her name, but she was a doctor working on like how to take blood in microgravity so we could better monitor astronauts on their way to Mars because we need better monitoring equipment if we're going to be spending years in space.
So much cool research coming out of the ISS. I mean, it's an orbiting laboratory for us to learn more. And now that there's a lot more private companies coming online to get into space, a lot of them are focused on satellite technology and things like that. But there's a bunch who are working on getting humans into space as well. You know, you hear about SpaceX a lot, but we also have Blue Origin and the Sierra Nevada Corporation, and there's several others who are getting involved in getting humans into low Earth orbit, and maybe even beyond that. And that's going to change space exploration a lot. I personally think another decade or two, and the entire realm of space exploration is going to have markedly changed from where it is now.
Yeah. And my last bit of a fun question. It's been joked around a lot by several different. I mean, the number of people who have said this have the sentiment is probably in the thousands at this point, but that our political leaders should be required to receive the overview effect before they take office. Would you agree with that sentiment?
So there's a famous quote by Edgar Mitchell in relaying his experience of the overview effect and of seeing our Earth from the moon. And in this quote, you know, he says, like, from out there, like, you see it in all its beauty and its splendor, and it makes you want to grab one of these politicians by the scruff of their neck and drag them the whole way out there, turn them around and say, now look at that, you son of a bitch, and just see this, you know, it's like, see what we are. And honestly, I think we have a lot more to learn about ourselves as humans, as members of our biosphere, and I think the overview effect, for me, is one of the two best ways to achieve that. I'm also really into meditation. And I think if we had more human beings learning how to meditate, how to practice mindfulness, and maybe more compassion, I think we'd learn a lot that way about ourselves and our ability to care for each other, empathize with each other. And then if we also had more people getting into space from more backgrounds, that's going to change things too. So far, less than 600 people have gone to space, and most of them are, you know, men from America and from Europe and Russia. There really haven't been a lot from other nations from around the world. We need more people from more backgrounds and perspectives, and not just scientists and people from the military, service members, and engineers. We need musicians and poets and politicians and lawyers and doctors and everyone. We need gardeners and welders, people from all kinds of backgrounds who have a different perspective of the world to see our Earth from space. Once that happens, it's going to change who and what we are and how we view ourselves.
Now that you've said that, I do want to ask one more thing, if you'll let me.
Yeah, that means yeah.
So another SpaceX thing. Have you heard that one of the first Starship launches they want to do is to go around? I think they're just. I don't know if they're doing a few orbits around the moon or if they're just going to the moon and coming back. But some billionaire like paid for all the seats on the first Starship mission to like, and he said he's going to bring like artists and poets and writers aboard. And I was just wondering what you thought about that.
Yeah, I'm very sorry. I cannot remember his name right now. A wealthy Japanese man.
Yeah.
It also got a little weird because he kind of turned it into like a personal dating thing.
Oh, he did?
Yeah, so he kind of opened it up for like young women to apply to be his partner on the mission and like end up marrying him. But I mean, there are cultural differences between, you know, the U.S. and Japan, and so maybe we were viewing it through the cultural lens of being Americans, but it did seem a little weird to me. But I did love his proposal. I think it was 6 or 8 people he had said he would take along with him on this trip, and you can tell that I haven't read on this for a little while, but I did love his idea of taking musicians and poets and authors and storytellers of all kinds. Because those are the people we need. I mean, I love our astronauts. Some of them are very good. Nicole Stott is an artist and has been an astronaut and has had the overview effect. Several people, you know, have gone to space and have done a remarkably wonderful job of relaying that experience. And so I mean no disrespect to those who've been astronauts in the past. And again, many of them are very good at sharing the story. But why not take people from different cultures and different backgrounds and different artistic backgrounds who use different media in language, in spoken word and written word, in poetry and prose, people who use different kinds of artistic media to express themselves, from sculpture to modern art to paint and all kinds of other realms. There's a lot of ways for us to share the experience, and I think having those people with different perspectives and backgrounds up there, it's going to make a huge difference.
Yeah, if only we could get a flat earther up there, I swear. Okay, well,
It would change things, right? They couldn't be a flat earther anymore once they see it.
exactly. Yeah, that was wonderful. Holy cow! Thanks for such a great interview. Is there anything else you'd like to mention, clarify, anything at all?
No. I mean, just one thing that I always love, reminding people of, though, is this idea that we are on this world together. One thing I love about astronauts who have relayed the overview effect, and one in particular is Mae Jemison. She said on a podcast not too long back that one thing that she noticed about herself is that she never gets angry in rush hour traffic anymore. And I think if we could just slow down and maybe breathe a little bit, maybe meditate a little bit, and maybe just think more on the fact that we are just floating through space on this fragile little orb together, that maybe we could be a little bit less angry with one another and impatient with one another and a little less focused on ourselves.
Wow. Yeah. I mean, as we all know, rush hour traffic is one step away from nuclear war.
Right? Yeah, I prefer to avoid it at all costs.
Exactly. All right. Thank you so much.
Yeah, it's been a pleasure. Always fun to talk.